Hello everyone, welcome to this MagiCAD for Revit webinar. Today we're going to be having a look at an overview of the electrical module that comes with MagiCAD for Revit. During the course of this webinar, if you do wish to ask any questions, then please type them in the questions pane, and if we have time, we'll answer them at the end of the webinar. If we don't have time, then we will email you and get back to you after the webinar and answer your questions. So if we start the webinar now, what we're going to do first of all is we can take a look here at some of our common tools, bizarrely enough, to start off with. Just a very quick kind of look at these, because we have a number of common tools which are non-discipline specific, which can help with the electrical design process itself. So I'm going to show you one of those very quickly. There are a number of these. There'll be separate webinars for these, but for now, I'll just quickly show you the spreadsheet tool. This can be used in conjunction with Revit's own color plans, and that will allow you to create very quick, easy strategy drawings. To use this, you can select spreadsheet export. You can choose the parameters that you wish to export. So I want us to export in this case against spaces, and I can choose a parameter set. I can save a selection of parameters as well, so that I can load them up and use them again at another point. So I can see there I've already saved a template for my parameters that I want, and it arranges them as I wish. So once I've exported that into a spreadsheet, I can then edit the data in the spreadsheet and assemble the data so that I can basically change the parameters inside these spaces. And when that's complete, I can then import the spreadsheet again. If I just choose the file there, then you can see here, oops, I think I've chosen the wrong parameter set there. So once you've selected the changes, you can actually, where am I? There. See the differences. So this is the original parameter that you exported, and then anything that's changed will be highlighted in red, like so. You can go through, you can review all of the changes that you've made. If you're happy with them, you click accept changes. It pushes that information back into the project, and I just need to change my view so that I can actually refresh this this view. And there we go. You can see that's now populated the spaces with the data. So it's something you can do within Revit out of the box, but in out of the box Revit, you'd have to select each space and then obviously change all of the parameters manually. This common tool just helps speed that process up. So to see other ways that we speed up processes within Revit, I'll take you through some of our modeling tools. These modeling tools are the same throughout the ventilation, piping and electrical modules. So if I look across here on the tool pane here, I can see I have all the same tools here in all three modules. So I'll just take you through what we would see in the electrical module. And you can use these tools to coordinate nice and easily within your model. So as you're drawing, you can actually coordinate objects in your model. So if I take a look here, I can see I have a piece of containment here. This is at 2,500 from the floor level. If I wanted to draw a new piece of containment, I can click on the cable tray tool. And this cable tray tool will allow me to choose cable trays which are loaded into my project. And then additionally, we also have systems as well. So Revit doesn't ship with electrical systems. We actually add these electrical systems into our own data set, which is our own kind of database of settings and products. I'll take you through that shortly. But you can see here we have different systems that we can choose from. These are all based on the Uniclass 2015 system classifications. So if that's something you use in your market area, we do actually produce localized templates for you to utilize this information. So if I choose a system that seems appropriate, I choose the type of cable tray that I want to use. I can also choose the sizes that I want to use as well. So in this case, I'm going to have 300 wide by 25 high seems okay. I can also select an installation code. This will be used just to fill a parameter. So if you want to export this as an IFC, for example, and you want to show a parameter that shows how this piece of equipment is installed, you can populate that parameter from here. So in this case, I'm going to say it's pendant mounted, so it's being hung from hangers that come down from the slab. And then I can also see here that I have various coordination tools. So I can coordinate this with the bottom of the cable tray, with the offset, which is the same parameter that Revit would use, and then the top of the cable tray as well. So depending on how I want to arrange my hangers and how I want to fix things and coordinate things, I can choose which of those offsets that I want to use there. So in this case, I'm going to align this to this other tray just so that it creates a situation where there would be an issue. So I'm going to choose center to center of, choose this tray here, and then I know for sure that this tray is going to collide and cause a coordination problem. Obviously, you would normally want to avoid that, but in this case, I'm going to give you a demonstration as to how we can rectify situations where that happens. So once I'm happy with all of my settings, I can click OK, and I can now draw straight away from here. I'm just going to turn automatically connect off, and I'm going to create a few problems here. So there's one, there's another one, and so on. You can see this would be a bad day at the office if you were actually modeling like this. So to avoid the situation in the first place, if you know as you're drawing that you are going to get a problem with products colliding, again, you can use the drawing command just the same, so the cable tray tool in this case, and you can draw up to where you think is appropriate for lifting your tray up or dropping it down below the one that you're going to interfere with. And then you can use this floating toolbar here, which has the angle to horizontal tool inside that. If I click on this, what this actually does is it loads a similar window to the cable tray selection tool, but in this case I can choose an angle rather than a system, and this will be the angle that I want to use to either raise or lower the cable tray by. I can choose to change the type of tray that I'm drawing, change the installation code, everything else, but the main thing that I can change here is the alignment. Now, if I want to draw this over the top of another object, I can uncheck this justification box here, and then my tools change so that I can draw on top of, or I can draw below, and I can also put a tolerance in there as well. So if I want to keep 150 mil clearance between the two objects and I want to draw it on top of another object, I click on top of, I click on the tray like so, yes, okay, and then once I have made all of my selections, I can see there it's updated the parameters here to account for drawing 150 mil above the top of that tray. So if I click OK now, that will actually draw in my setup for me. I can draw across, And then again, I can come back to my angled horizontal tool if I want to set that back down to its original height again. So again, very straightforward process. I just remove my tolerance, change that back to 0, click at center of the original cable tray height there. And once it's made all the adjustments, I click OK, and it draws my set down back in. And there you go. That's all nicely coordinated without even having to leave my plan view. So I'm just going to open up a 3D view here just to show one way that another way that we can approach that situation. So if I open my 3D section box here, I'm going to create a new view. This is going to be containment, and I shall use this coordination template. There we go. So there's a nice 3D view of that situation. So using this and my original view, what I'm going to do is just again deal with this situation. So aside from drawing your coordinated services in the first place, that obviously requires a lot of knowledge about everything that already exists in your project. If, however, you come to a situation like this where something already exists and you have some interference, you can actually use some of our other tools to deal with this. So another one that we have here is our vertical crossing tool. If I click on that, I can use various different options. This particular floating toolbar here just released with our latest update release, which came out last week. So if you've not upgraded to the latest version yet, or that you've seen this for the first time, then I'm not going to go into the details of how these different options work. Again, that will be in a separate webinar where we focus more on the actual tools that we've updated in the latest update release. But for now, if I choose an option as to how I want to cross these objects over, what I want to do now is select the tray that I want to adjust, and then it asks me to select the segment that I'm crossing over, so the tray that I want to cross over the top of in this case. So I select that, and then in this case it automatically chooses where my start and end point should be. And again, I get a similar tool here. I can pop out a 3D preview of this if I want to see how this is going to look once it's coordinated. I can see there I've got a nice preview to look at. And again, I can select the angle that I want to do this by. So in this case, if I choose 30 degrees and then again 150mm tolerance between the objects, click update, then I can see it's updated my 3D preview here. I can see it's also updated in my 3D view as well, if I want to view that, if you've got the views open the same way as I have. So you can see from this that it's a very straightforward way of seeing how to coordinate these services. When you click OK, it places all of those objects in the model. These now become the exact same as standard Revit fittings. So there's no difference between this and a standard out-of-the-box Revit model at this point. MagiCAD is simply performing that task for you. So additionally to that, we also have a multi-crossing tool. So this works in exactly the same way. So I choose the trays that I wish to coordinate. So in this case, I'm going to choose these three. I'm going to do them all at the same time. Click Finish. Choose what I want to coordinate with. And then again, it's going to make some decisions for me. It's also going to remember my settings from the last time I used the tool. So it's remembered that I wanted it at 30 degrees with 150mm tolerance. And if I'm happy with all of those options, I can click OK, and you can see it does all of those all at the same time and offsets them all in a nice uniform manner so that it's nicely presentable as well. Now, this doesn't just work with cable tray, it can also work with conduit, it can work with pipe work, ventilation, duct work, and that can be either rectangular or circular. So this works across the board with all of the similar drawing tools that you may use. To give you an example of how that can work, if I just adjust my views here for a moment. And find the piece that I'm looking for. So this can also be used in the horizontal plane. So if I look in here, I don't think I've got the piece to coordinate with in my 3D view. Okay, let's try this again. There. There we go. So I can see here I've got another example where I have a piece of cable tray which is now obstructed by, in this case, a duct, but this may not be a duct. It could be easily be a structural beam or some other fixed component that can't be moved. So in this case, moving the duct around the tray is not going to fix my problem, and lifting the tray up or dropping it down is also not going to fix it. So this time I can use my horizontal crossing tool to perform the same function, but in the horizontal plane. So I'll just adjust this view so that you can see the duct that this is conflicting with. Oops, there we go. So ducts, there we are. So now I can see this cable tray is obviously clashing with this object here. So again, I come up here, choose my horizontal crossing tool. This time I'm going to use a different one of these options. I'm going to choose a start point and an end point. And I now need to choose the face of the object that I want to coordinate this with. So I'm going to choose the outside of this duct here. And then I can see, again, I get a similar looking tool. I can pop out a 3D preview if I wish to see, exactly how this is going to work. And with this tool, I can choose the crossing direction. So which side of the object do I actually want it to coordinate with. If you end up in a situation like this, where obviously I've chosen this side of the duct to coordinate with, but if I wanted that crossing to be on the other side, I can then choose a tool in here, select a new point to coordinate with, and it will work out what I need to do to push that around. So it's very, very simple to use this tool. Again, if you want a tolerance there, say I want a 50 mil gap this time, I can click update again and it will push that out. It does show you the minimum and maximum amounts that you can push this around as well. So you can, if you end up in a situation where it says it doesn't have enough room, then it will tell you what the minimum amount of space required is based on the fittings and your routing preferences. So depending on the sweep of the bend and the length of these fittings, obviously that's going to affect how far this can offset and what the minimum required to offset is. Again, that can be adjusted by selecting different angles and therefore different fittings to suit your needs. Once you click OK, then again, that's then placed into the model like so. This can also be used in if you imagine in section view as well. So say this was a drainage stack, for example, then you needed to divert that around a structural beam or something. Then again, you can use the horizontal tool in the section view and it will perform the same function. Likewise, we also have a multi-horizontal crossing tool. Again, that works in the same way as the multi-vertical crossing tool, but in the horizontal plane. So I'm not going to waste your time showing you that. It's exactly the same as before. Okay, so as we saw earlier, we have let me just sort this view out. There we go. So we have the crossing tools, which allows you to deal with situations where you already have issues. Another tool that we have here is the angle to horizontal tool, and what that does is the same as we saw earlier while we were drawing. If I click on angle to horizontal and click on the end of a cable tray, then this works exactly the same as it did before. I can continue drawing this cable tray and adjust the angle and height that I want to use this at. If I know for a fact what height I need to adjust this to, I can actually type that in there. I don't have to use these tools if I don't want to. And when I'm happy, I click OK, and you can see it draws that in for me. I can continue drawing from there. Additionally, you can use this tool on the side of a tray as well. So if you want to create a branch that's coming off and you want to drop that or raise it as you come off the side, again, you can use the angle to horizontal tool, click on the side of a tray, and then again, use all of the same parameters as before, but this time I'm going to choose, let's say 2900 in this case. And then I want to draw that off this side, then it will put the minimum amount of fittings that Revit will allow for drawing that adjustment in height as far as I've specified. Now, obviously there is a bit of tolerance here. You can move these pieces around as you normally would in Revit, but because Revit has very strict rules on how it can put these fittings together and what distances it can put in there. Obviously, there may be some adjustment required in this tool, but it will, rather than you having to manually draw all this in section view, it will put all of that in for you, and then you simply need to adjust the length. Okay, so the last one that we can look at here is the standard connection tool. With the electrical module, there is only one type of product that this will work for, which is conduit. And that's because the standard connection tool, the way that that works, is it will find the best method to connect two circular objects together. So if it was circular ductwork, or if it was conduit, then it can use, it can rotate fittings, use the least amount of fittings, and connect things together. Now, we have also developed this to work with rectangular ductwork, and we're currently working on getting it working with cable tray as well. But obviously, there are other challenges involved with that, because you can't rotate a fitting in a rectangular object through 45 degrees, for example, because then obviously it will break your ductwork or your cable tray run. Again, that works similar on rectangular objects as it does to the angle to horizontal tool, in that it will bring a branch off to the minimum size it possibly can, and then draw any height offsets from there. So to use this tool, again, you can do all of this from plan view. It's all of our tools are designed in such a way that you can run through and use all of these in plan view. What I shall do is I'll actually jump, in this case, to ventilation view, because it works in exactly the same way with conduit as it does with ductwork, and I actually have a good example here already. So if I take this section here, for example, and just create a new view for that. Okay, so we can see here we have two sections of ductwork, and if I just have a look at this here, I can see I've got an offset in the vertical plane as well as an offset in the horizontal plane. And not only that, but I want to actually connect this duct into this elbow here. Now, Revit has its own method of doing this, which would be, if I select these there, you can see Revit has routing solutions, although some of those solutions may not be the best solution or the solution that you want to use. Again, it comes down to modeling this exactly how you want, and usually you would have to do that manually. It can be quite a drawn-out process. So the reason the standard connection tool exists is just to shorten, again, that process, and you can do it all from plan view. So if I click standard connection, I'll choose this elbow here and this duct here, and what it will do is, again, I get a 3D preview. I can go through and select different options to see exactly how I want to perform this task, and I can choose as well if I was creating a branch using this tool, because you can use it to break into a solid object as well. Then you could choose the junction type that you want to use when you break in. But in this case, I'm just connecting to fittings together, as it were, or one duct into a fitting. So when I click OK, I can see it's only used 2 fittings to achieve that. It's converted that elbow into a T, and if I have a look in my 3D view here, I can see exactly what it's done. So it's rotated these fittings around and positioned them in a sensible way to actually connect those 2 systems together or rather those 2 objects together in a reasonable and sensible fashion. Okay, so that's basically the overview of the coordination tools. We have other tools as well which help you draw. Again, in the latest update release, we've also added cable tray and conduit series to our data set. So as I keep talking about the data set, I'll show you what that actually looks like. Here is, in this case, this is a standard UK data set. In here we have various different products, different settings, all of your different systems like so. So you can configure your own systems. You can add to this list if you wish. You can modify the information in this list, and you can specify IFC colors from here as well. So if you export this information into IFCs, you can replicate your system colors throughout when you export them to IFC by defining the colors in here. Additionally, you also have defaults. So these are default power circuit types in this case. So we have here single phase lighting, single phase power sockets, etc. And then likewise we have components. So if I were to look here, I've got a whole bunch of different sockets that I could select. I have switches and so on. Now, all of these products in this data set are not the full range that we provide. We do have what we call MagiCAD, which allows you to connect to our online database and download a lot more products. We have over 1 million MEP objects in our database, so there is a lot to choose from. If you wanted to add a product to your data set, there are many ways of doing this. You can do it through the data set itself, like so. You just right click on new, and then you can select the objects you wish, fill in the data that you want, and you can associate a 2D symbol with that as well. Additionally, in here you have various other options which again we'll explore shortly, but in this case, if I show you how the MagiCAD works, if I click on MagiCAD here, then what this will do is it will open a web-based browser, and it will allow me to view all of the there we go, view all of the products in the selection that I wish, and I can filter these down by manufacturer, type. If I know the name of the luminaire that I want to use and I know it's in our database, I can search directly for that as well. So you can see here we've got a number of objects that you can choose from, a number of different manufacturers here, and you can go through, select the object that you want. I'm just going to choose this for now. If I click on this pendant luminaire here, then I can view this in our browser, see is it exactly what I want to see. I can select an image, which is a static image. So if I've got a deliverable where I need to show the luminaires that I want to use, for example, I can just download this image and insert it into my document. And then you've got dimensions in here as well. If you're happy with that, you can click insert, and what that will do is it will download the geometry and all of the information that goes along with that, and it will start to fill in all of this data for you. So from there you can give it your own code. So say this was going to be my I don't know, my F1 type fitting. I can put my own user code in there that says F1, and then in my legend I can actually reference that parameter and give a description to that to say this is going to be, in this case, Sobra pendant luminaire. So once you've selected all that, you can then choose a 2D symbol. As mentioned, these 2D symbols are customizable. You can create your own 2D symbols. Again, I'm not going to go through that today. That's for a separate webinar again. But if you select your appropriate symbol for the luminaire that you want to use, I'm just going to use this one for now. Then once all of your data here is populated, you can actually click on that and insert it into your project, and it will assemble that then into a Revit RFA. So it's not going to exist in your project as some kind of strange object from a different software company. It will be a Revit RFA. So that removes issues with compatibility or work sharing, or if you need to deliver this model to a client, then, and they don't have MagiCAD, then they'll still be able to see all the products, they'll still be able to see all of the data that goes along with them, and you'll still be able to use them for your designs. So that's kind of an overview of the data set. That's the settings and products behind MagiCAD. So what we'll do now is we'll have a look at how we can use some of those products practically. So if I go to a lighting layout here, just close my 3D view, there we go. So I can see here I have a layout. I have spaces set up in here as well. This is just going to help me place my objects because the standard way of inserting products, luminaires in this case, into your Revit projects is basically point and click, and then you would have to adjust them after the fact and position them exactly where you want them. So in this case, I'm just going to use this 600 by 600 luminaire here as an example, and if I click OK, what I'll notice, and this is the same for all products that you insert through MagiCAD, again I get a floating toolbar. With this I can use coordination tools again here, so I can actually define exactly where I want to position this height-wise in my project. I can also choose here my Uniclass code in this case, and my installation code. So how is this actually going to fix to the objects? Obviously wall surface in this case is not correct because it's a recessed fitting, so I can change this on the fly as I come to actually fit the products into my project. So you're not kind of limited to only what it says in your data set, you can adjust things as you go through. So additionally to that, you'll notice we also have this array function here, and what this allows me to do is, obviously I've got different methods of using this array tool. For now, I'm just going to concentrate on select space, and I'm also just going to concentrate on number of instances just for speed. Obviously, you can use different methods to position your arrays, but in this case, I'm just going to have a quick example. So here I can see that I'm going to put a number of instances, 1 column, 2 rows into these offices here. I click on the space itself, and then oh, that's interesting. I don't think I've got my view template set up properly, but it will position the luminaires in the space. Let me just readjust this view template. I'll tell you what, I'll do this easier. I'll do it on the ground floor. There we go. So again, install product, this one, and then I'll use my array tool in my floating toolbar, number of instances. So this time I'm going to want, what am I going to want? 3 columns and 2 rows, let's say. And I can click on the space and it will position those luminaires. There we go, 3 columns and 2 rows. If I think maybe I want to adjust this because 3 columns is not quite enough, then I can change that to 4 if I want. Click update and it'll update the array there. And then if I'm happy with everything, I can click apply. And then at that point, it assembles those RFAs and fixes them into my project. So these are now, again, Revit RFAs, just the same as any other. You can change them for another product the same way that you would in Revit out of the box. Additionally to that, we also have a find and replace tool, but again, I'm not going to go into the details of that, but we have many non-discipline specific tools which you can use alongside the electrical module to help provide the look that you're after. So now we've inserted products into our model. I'm also going to take a look now at another way of doing that in the case of luminaires. So this is a bit more useful because it allows you to calculate as well, and we do that by exporting our spaces to Dialux. So I can use the Dialux export tool. In this case, I can select, say, these 2 spaces here. Click finish. I could select all of the spaces on an entire floor if I wanted to, and this will export to Dialux 4, so not Dialux Evo, at least not at this point, but it will export to Dialux 4 and basically allow you then to, so if I choose Dialux export, for example, then I can export those spaces, open them up in Dialux, and it will then show the geometry, the spaces that I exported. So if I quickly open up Dialux here, I can see if I import an STF file, which is the file type that we saved. I'll just browse to that. There we go. So there you can see it's now built my geometry for me. I have the 2 spaces that I selected in my model, and it's assembled that. I can then use Dialux to add luminaires, do all of my calculations, print off all my reports, whatever is required as deliverables, and then from there I can then export that as an STF and bring it back in. And again, I've created one of these ahead of time just to save time. I don't want to show you how to use Dialux. That's not what this is for, but I can see here I've created something within Dialux itself. I've created some luminaires, done some calculations, and I'm going to bring this back in now. So if I click open, I can choose the room that I want. In this case, it's this meeting room 135 that I've done the example on. So I can import from there. And what this is going to do, you can see here, this is a luminaire that we don't have in our own library, but it's still going to use the that product, because it's going to download the information from your Dialux project. So what it will do is it will download the 3D geometry that Dialux has, and it will assemble that along with all of the parametric data that you can see here, and then also you can choose from your library an appropriate 2D symbol. So let's say this one, for example. Click OK. So there's my 2D symbol. I can select a user code again. So say this is my A1 type fitting. Use that in my legend again, and then I can choose the uniclass system from here as well. So general space lighting. This question that pops up is if I had a list of multiple different luminaires, then I can choose to use the same system, the same uniclass system for all of them all at the same time, or I can choose not to and do it manually. So here again, I can choose the description. So if I'm not happy with the description that comes through from Dialux, I can write my own description if I wish. I'm going to just select Project North, and then when you're happy with everything, you can click Import, and then this is actually going to kind of jumble up these luminaires, but we'll arrange that shortly. So I can see there it's imported 6 luminaires and it's placed them into my model exactly where they would be in my Dialux calculation. Let me just select all my original ones and get rid of them. There you go. So it's brought these in from Dialux. It's assembled the geometry. I can see here the geometry is actually just kind of a small flat cube shape. But it's built that RFA, so it can now be used in the model. Again, you can use you can replace this with a different luminaire, so say the actual manufacturer's luminaire if you wish, but it will keep the positioning exactly the same as it was in your calculation to ensure that everything is correct and positioned correctly. Okay, so beyond this, the Dialux tool itself, obviously that's a very, very brief look at it. We do provide training with all of these tools. If you decide to take a trial or you decide to buy MagiCAD, and we do provide full training in how to use all of these tools in great detail. But now we actually have those objects in our model. We need to circuit them up. So we can have a look now at our circuiting tools. One point to mention when circuiting is with our MagiCAD templates, we provide these panel board schematic templates. Now, if I have a look at one of the templates, this is what they actually look like. So these are a deliverable, not so much in the UK, but in other market areas like Spain. I believe they are also used in France and Switzerland as well. These are actually a project deliverable. So we give you a template for this, and using our circuit management tool, you can actually populate all of the data in here automatically from the circuits that are in your project. Alternatively, you can also detail these without having the panel even or the circuits in your project. So if I have a look here, I have this example of in this case panel board 2, and I have some circuits attached to panel board 2, but panel board 2 doesn't actually exist in my project. So if I wanted to attach this to my project, then I can do at a later design stage. I can actually place the panel board in my project, and then I can link these circuits with that panel board in my project. And if I actually create the Revit circuits as well, I can link all of this information, and I can push information from my schematic into my model, and I can also push information from my model into my schematic as well. So this is a good way of keeping track of your your circuits and issuing them as a deliverable. Here in the UK, like I say, we don't really use these, but we do use DB schedules. So it's important to get all of this information correct. Again, you could set these up. This is just a title block on a sheet. These are just families. You can edit these and show whatever information, whatever parameters you want, and put them together in an arrangement that suits you. Yeah, effectively, you can use these to detail or plan your circuits at an early stage. And then if you're using an external calculation software, then you can also use these to plan out your circuits in your calculation software, run your calculations, maybe change some information as required as a result of the calculations, populate that information back into these schematics, and then again you can push that information then into your Revit model based on whatever process you've done with your external calculation software. So again, as an example to show how this works, if I have a look at my lighting view here, then I can see I've already started populating some circuits. So these actually exist in my model. If I click on Manage Circuits, then what I'll be able to see is, it's popped up on my other screen, hang on, there we go. So I can see here, I can view panels from the project. So the panels that actually exist in my project, I can see in this view, and then any circuits that are physically connected to those in Revit will be populated in these circuits here. So I can see this is a data cabinet. I also have my ground floor distribution board, which if I select that, I can see I've got a number of circuits connected to that. I can also see from here that these circuits have way numbers and phases, and they seem to be in kind of a random order at the moment. They're kind of all over the place. So if I have a look at my panels from my schematic, what I'll be able to see here is this is how they appear on my schematic, and I can see 101, 102, 103, 201, and so on. So I can actually arrange these. If I show the panels from the schematic, I can arrange these circuits however I want, and then this green kind of icon on the left-hand side means that it's actually connected to the actual circuit in the Revit project. So I can use my automatic circuit numbering tool here. As long as these circuits are arranged in the correct order, then I can use this tool and automatically number these appropriately for the circuit ways. And then that again helps me with tagging. It populates a parameter that I can tag, and I can tag the DB name and the circuit way. Again, we have a common tool which allows you to push those parameters together. So if you wish to take your DB name and circuit reference and push them into one parameter, we have a merge parameter tool that allows you to do that. Again, I'm not going to go into detail of that today, but here we can see that we can adjust these circuits however we want to present them, independently to how Revit organizes them in the project. So again, like I say, if I wanted to merge circuits in my project together with circuits in my schematic, then I can use this Manage Links tool. I'll give you an example of that now. So if I go to my schematic, I want to add another circuit to this, which doesn't currently exist in my Revit project. So I can click Set Properties on here. I can define what that's going to be, what type of cable it's going to use. So here I can say, let's see, it's going to use flat twin and earth. I'm going to choose a bit of a rebellious installation method for that. People in the UK will understand what I mean by that. And then this is going to be a single phase lighting circuit. I can see it started selecting protective devices and things like that for me, which I can of course adjust as I need to. I can give this name a load, so I could say this is going to be meeting room 135. Oh, I want to start that with lighting, don't I? There we go. So this is lighting in meeting room 135. So I can see from my description there, it's defining exactly where this is. I can choose from here a symbol that I want to use on my schematic. So again, we have various different market areas in here, so you can choose the one appropriate to your market area. And when you're happy, click OK, and it will create that. So that doesn't exist in my Revit project, but it does exist in my schematic. So now what I can do is I can have a look at my schematic, which will be this one here, I believe. Yep, there we go. So that is the circuit that I just created, lighting circuit there. I can see that it's not associated in the same way that these are, because these are associated with the actual circuits. It's automatically populated the load and current on there. I'm going to do the same thing now. I'm going to basically associate this with a circuit in Revit, and to do that, all I need to do is create the circuit as you normally would in Revit. Choose the appropriate panel, like so. So that's now a Revit circuit attached to the same distribution board. And if I go now back to Manage Circuits, then what I can do is select the circuit that I've just created. When it decides to load up, there we go. So if I go to Manage Links now, then here I've got my ground floor distribution board. There I can see that's my lighting circuit. It's not very detailed, but because it's not got any of the information that I had on my schematic in it yet, and it's also given it a 20 amp rating as well. So this isn't currently associated, and then this is the lighting circuit that I did create, which it also isn't associated. So I can click on that circuit, and tell them to link, and then they'll push data around together, and I can see here it's now changed that to 10 amps as per what I had specified in my schematic, and it's also picked up that it's a lighting circuit. It's pushed that information both ways, because you can see here the load name, it's actually taken from the Revit circuit itself. So it's a very simple way of managing the information in there, and then again, if I wish, I can select this from schematic view, and I can actually give this a circuit name or number even. So in this case, it doesn't have one. I can see that my next available one in my on the lighting side of my board here should be 2L3. So I don't currently have the numbering rules in here, so I'll just add manually. No, I won't. Let me just change that. My apologies. I've not updated my data set. So the numbering rules in here, let's put TP and N. There we go. Number of digits, 1. Yep, and that's going to end in /L 1 to 3. Okay. There we go. So I've now created a numbering rule there, and I can see the way that that's going to work is it's going to start from 1L1, then go to 1L2, 1L3, and then go to 2L1, and so on, which is how we would normally do it in this country. So again, if I go back to Manage Circuits now, I can actually add that way and phase description to here. So I can see here, this is my automated numbering tool, and I can use my next available number here. So if I show this as 2L3, like so, then that's my next available number. I can click on this circuit, I can click apply, and it will then add that to there. So like I say, this is relatively independent of Revit's own circuiting tools, and the actual the actual panel board schedules that Revit uses can still be used to push things around onto the appropriate phases and things like that. But this will allow you to much more easily manage those circuits, number them exactly how you want to, and produce a deliverable based on that. So very quickly, we've got about 4 minutes left. I'm going to have another look at something else that can help you out as well, as far as schematics go. With our new schematics module, we can see here you can draw schematics in Revit. So this is basically a very straightforward way of doing this in Revit. We give you various symbols that you can use. You can create, again, your own symbols to use as well. And when you're using these symbols, it's much the same as using CAD blocks in AutoCAD. So you just select the appropriate device or symbol that represents what you want to show, and then you can place that object into your schematic. So in this case, if I choose a distribution board like this, then I can place that in my schematic. Maybe I want to change that fire alarm panel there for that. Then you can see there it's quite a straightforward process to create these schematics. Beyond that, what you can then do as well is you can actually attach and associate these with objects in your Revit model. So in this case, I have a panel board here. I'm using this line to represent a panel board. I've already placed a tag here that's going to pick up the name of that panel board. And then I've made some other adjustments as well in my model here. So I have my ground floor distribution board here, which has changed its name from DBG1 to DBG5. It's also changed the amount of load because we've added load to it. I've changed the cable type, and I've also included a cable length using our cable packet tool. That's, again, another feature that's worth exploring separately because there's so many facets to it that it's worth kind of exploring that in a different webinar. But the cable packet essentially gives you a cable route that you can follow. It will automatically generate your cable length based on the actual route that follows your containment, and then you can also tag it to show how many circuits you have attached to it, what those circuits are, what their circuit references are, what the cable types, etc., etc. You can load it up with all kinds of data. So again, we'll have a separate webinar on the actual cable packet and how that works. But for now, I want to associate this line here in my schematic with my panel board. So if I click Create Link here, and then I want to open up a view where I can actually see that panel board. So my lighting view has it in, I can see that here. And I can then link this with that panel board like so. You can see that's now changed green. So that wire line there is now associated with the switchboard. So I can close that. And what I can do now is I can map those parameters that I want to update. And if I have a look here, I can see I can use this to actually map the parameters across. So I can choose what kind of product do I want to select parameters against, what parameters in the actual model do I want to use, and then what in the schematic, which parameters do I want to associate those with. You can push these from your model to your schematic, or you can push them from your schematic to your model again. So you can update your model using your schematic if you wish. What I'm going to do is, again, I've made some earlier, so I'm just going to select my mapped parameter file, and this is going to be, where is it? There. Okay, so now if I have a look again at the same map parameters file, I can see I have a whole bunch of parameters that we've already mapped for this this demo project. And if I click synchronize parameters, then this will show kind of the power of this tool really. Again, I get a preview. I can filter through all of the information that's changed. If I'm happy with it, I can click accept changes. I can see there. So it's now picked up that that's associated with PB1. It's also changed my cable type there. It's given me a length. It's changed my board name and updated my load. So that's kind of a really speedy overview of how this this works. We have already recorded a webinar specifically for this. Have a look on our website for the schematics module product feature. So that pretty much concludes today's webinar. It is quite a long one, granted. Thank you very much for sticking around and watching it through. If you do have any questions or you wish to speak to us to arrange an interview or find out more information, then the contact details are just popping up on screen for you now. So you can get in touch with us via these usual methods. Alternatively, on our next slide here is some contact information so that you can get in touch directly. If you wish to arrange a demonstration, or if you wish to maybe arrange a web demo, or you just want to ask questions in general about anything that you've seen today, then please do get in touch and we'll be more than happy to help. All right, thank you very much for attending, and I wish you a good day.